Okay, so number 26. So we have two masses. Now this problem incorporates the two final things in this chapter are solving problems on an incline, solving problems on a pulley, and here we have both. We got incline and pulley. So look, the way we're going to solve this, free body diagram, we're going to do two. There's two objects, so we do two free body diagrams. Sum the forces for each object, and then solve the algebra. So chapter 4, it's very much a write your own equation chapter. All right, so I'm going to do the free body diagram right on here. So I'm just going to erase this rope so we can put our vectors on, erase this. I mean, the rope's still there, but I'm just going to take it off so we can do show the forces. All right, and then let's erase. So this guy's the 5. Get that out of the way. This guy's the 10. Okay, so let's do free body diagram. So what are the forces acting on? So we'll call this guy M2. This guy is equal to M1. And then up here we'll say M1 is the 5 kilogram. M2 is the 10 kilogram. All right, so what are the forces acting on M2? mg down. Now don't make sure you don't just say mg. You got to say what? M2g, because there's two masses now. So say m2g and m1g. Okay, what force is acting up on this guy? Tension. Okay. Any other forces acting on? Any other forces on this guy? Nope. That's it. Okay. Now let's go to M1 sitting here on the incline. So what forces are acting on M1? Well, we got mg, or that's m1g. Is there a normal force? Yeah. How do we know there's a normal force? Because it's on a surface. So the normal force is like that, always perpendicular to the surface. That's why we call it normal force. Normal means perpendicular. And then there's one more force. Tension. So tension, the rope is pulling that way, parallel to the incline. There's tension. Okay, for objects on an incline, what's the thing we do to simplify the problem? And you don't have to do it. You could really just, be stubborn and not take my advice. It's solvable if you don't do this, but life will be a lot harder. So what's the thing we do to simplify this dramatically? We tilt the xy. We're going to say that the incline is the x. So there's the x-axis. There's the y-axis. We tilt the xy axis. And why do we do that? The reason we do that is so now the acceleration, so which way is M1 going to accelerate? It's going to accelerate along the incline, right? It's going to accelerate that way. So now the acceleration will be perfectly what? X. The reason we tilt the xy axis is so then the acceleration is perfectly x. And then what can we say about our y acceleration when we get to that point? It'll be 0, right? That's the reason we tilt the xy. Now, okay, so what's nice about the normal force? Normal force points what? Perfectly y. What's nice about tension? Tension points what? Perfectly x. Okay, what about mg? Mg, what do we have to do to it? Break it into components. All right, so with the red pen, right there is the y component of mg. Mg y component. And then right here is mg x component. Okay, and then what's this angle going to be inside here? You can prove this with geometry. That angle is going to be what? The same as the incline. Right? It's the same. Whatever the angle of the incline is, you can prove that the angle in there is the same. Okay? Now, sign conventions. This has to do with pulleys. The big thing with pulleys is the sign convention wraps the pulley. Okay, so which way is M1? Which way is this block going to move? Or which way will it accelerate? It's going to accelerate up the incline. So let's say, so our sign convention is going to be like this. Bless you. Our sign convention is going to go like this. It's hard to write. It's hard to write at an angle. So we're going to say that up the incline is what? Positive. Down the incline is negative. Make the direction of the acceleration positive. Okay, now what about the what about the y direction? Well, for the y direction, plus, minus, like that. So there's our sign convention. Now, what happens to that sign convention as we go around the pulley? The sign convention wraps the pulley. So over here, what's our sign convention for M2 going to be? Down is positive, up is negative, right? This sign convention here, the one I'm circling, that sign convention wraps the pulley, you know. So, because if we say the acceleration for M1 is positive, and then the acceleration for M2 is negative, then we've contradicted ourselves. So the acceleration wraps the pulley. Okay, so now we're ready to sum the forces. So we have the problem set up. So we're going to get some more room here. You guys still see that? All right, so starting with M1, we're going to sum the forces X. We're going to sum the forces Y. Oh, and one thing I want to mention, notice there's no friction for M1. The reason there's no friction is, see this word right here? The crate lies on a smooth incline. Smooth is another name for frictionless. That means frictionless. Okay, so how many forces do we have in the x direction? And remember, the x direction is the incline. The x direction is this way. This is the x. How many forces do we have in the x direction? 2. We have tension, positive or negative? Positive, it points up the incline. So we have tension, and then what's our other x force? mgx, this guy right there. Okay, positive or negative? Negative. Why is he negative? Which way is he pointing? He's pointing down the incline. Okay, now what you're not going to do, you don't want to do this. T minus mgx. That's not going to help you at all. What do you got to do? You got to put mgx in terms of mg using trig. So if you look at this triangle right here, when I broke mg apart, all that is a right triangle. That's all it is. What's the hypotenuse of that triangle? This triangle that I circled. What's the hypotenuse? m1g, the black vector there. All right, so how do we get mgx? mgx is going to be sine 40 m1g. Okay, any other x forces? Nope. So what is the sum of the forces always equal to? ma, but don't just say ma, you got to say what? m1a, and then this acceleration is our x acceleration. So we just wrote an equation that's going to solve the problem. All right, in the y direction. Now we're not going to need the y direction here. The only time you need the y direction for a problem like this is if there's friction, because what does friction depend upon? What's the equation for friction? Mu times normal force. Do we have friction in this problem? Nope. Typically, you only have to sum the forces in the y if there's friction, because you have to find the normal force to get the friction. But this problem doesn't have friction. But let's just do it to be complete. We're not going to use this, but let's do it. In the y direction, we have what? Normal force, so the y direction's this way. There's the y. We have normal force, and then what else? The y component for mg, which is cosine 40 m1g. And that equals m1a in the y. Is the block accelerating this way? Is there an acceleration that way? Nope. And this is the whole reason we tilted the xy axis, so we can cross this y acceleration to 0. There is no y acceleration. Okay, now we go to M2. Okay, M2, so looking over here, remember down is plus. So summing the forces for M2, we're going to get M2G minus T equals M2A. Okay, we now have two equations and two unknowns. So we're not going to be using this y equation. This y equation doesn't apply to this problem. So what we're going to be doing is we're going to be taking this equation here and this equation here. What are the two unknowns? We have two unknowns. What are the two unknowns? T and A. Tension and acceleration. So we put the equations together. So take this equation, solve it for T. T is equal to M1A plus sine 40 M1G. Then take this equation, T equals M2G minus M2A. What do we know about the T's? They're equal. If the T's are equal, that means the right side of the equations are equal. So now we got M1A plus sine 40 M1G equals M2G minus M2A. And then you can solve this for A. The only thing missing is A. So let's see, I'll do this in one step. So this is going to be M2G minus sine 40 M1G all over M1 plus M2. Then you punch the numbers in, and you'll get 4.4. The acceleration is 4.4 meter per second squared. And then once you have the acceleration, how do you find the tension? Well, come up here. You have two equations for tension. Here's an equation for tension. Here's an equation for tension. I would take the second one. So you plug into this, and you get T equals about 54 newtons when you punch the numbers in. Or you could have done this equation. You get the same thing. All right, any questions? Good.